Hello everyone. In the first part, we have looked at the basic understanding of the three important classes of chemical compounds: acid, bases, and salts. In this video, we look at the theories that were proposed on classification of chemical substances, particularly into the acid and base categories. Now, while we broadly looked at some of the properties of the acids, as they have a sour taste and they will be corrosive in nature, and the properties of the bases as they being bitter in taste and they will be soapy to touch, there is a whole host of other aspects that we will be learning in terms of the properties of acids and bases. Now, in order to cover the chemical compounds in the classification into these two categories, acids and bases, there has been not just one theory but three prominent theories that explain how we can classify the substances into acids and bases. Now, we need to understand one thing, that the reason why there are these three theories is because any one theory is not able to explain the classification of all the substances into acid or base category. So we will try and understand what these theories are and how they will classify the substance into an acid or a base. So the three prominent theories are one is the Arrhenius concept, and second is the Bronsted Lowry concept, and third one is the Lewis concept. So these three theories, they will try to explain how we can classify the substances into being acids or bases. Starting with the Arrhenius concept, as per the Arrhenius theory, an acid is a substance which gives hydrogen ion. So H plus ions are basically hydrogen ions in water. So whenever we take water and we dissolve the substance into water, we will see that if it is an acid, it is going to be giving us H plus ions on dissociation. So what actually happening is dissociation of the particular substance. Like if you take HCl and we dissolve this in water, so water is the aqueous medium, we dissolve this in water, what we will see is it is going to give us H plus ions and Cl minus ions. So this is what we are looking for. So any substance when dissolved in water can give us H plus ions. We will be calling it as an acid as per the Arrhenius concept. Now, apart from HCl, we also have, like, sulfuric acid, H2SO4, nitric acid, HNO3, phosphoric acid, H3PO4, acetic acid, CH3COOH, formic acid, HCOOH. So we have various other types of substances which when dissolved in water can give us H plus ions. So all of them we will be calling them as acids as per the Arrhenius concept. Now when we look at the definition of base, base is a substance which gives hydroxyl ions. Hydroxyl ions are basically OH minus ions. So bases will give hydroxyl ions when they are dissolved in water. Same way, if we take water and dissolve a substance, if the substance is giving OH minus ions, we will be calling that particular substance as a base as per the Arrhenius concept. If you look at compounds like sodium hydroxide, potassium hydroxide, when we dissolve them in water, what we'll be getting is OH minus ions, hydroxyl ions. So we can understand one thing, that in the Arrhenius concept, the definition of a substance as an acid or a base is related to water. So when we dissolve the substance in water, if it is giving H plus ions, we will call it as an acid. If it is giving OH minus ions, we will call it as a base. So without dissolving in water, we will not be able to classify the substance as an acid or a base. Now in the definition of Arrhenius bases, we have seen that substances like sodium hydroxide, potassium hydroxide, when they are dissolved in water, we will be able to get OH minus ions, and the bases that are water soluble will be called as alkalis. So that way all the Arrhenius bases, since they are dissolved in water, we will be able to call them as alkalis. Now there is an classification of acids and bases as strong acids versus weak acids and strong bases versus weak bases. So this is based on the extent of dissociation. So how much the substance can actually undergo dissociation. Like say for example, if we have acid like HCl and it is going to almost undergo like complete dissociation. So we will be calling it as an strong acid. Whereas if we have acids like acetic acid is CH3COOH. It is an organic acid. We will see that later what is this organic acid, and acids like HCl we will be calling them as mineral acids since they are prepared from the minerals. So if you take acetic acid, it also will undergo, when dissolved in water, it also will undergo dissociation, but this will not be complete dissociation. So acids like HCl, H2SO4, HNO3, we will call them as strong acids, whereas acids like CH3COOH and even formic acid HCOOH, organic acids generally, we will call them as weak acids. So strong acid is an acid that will undergo almost complete dissociation when dissolved in water. Weak acids will only undergo partial dissociation. They will not undergo complete dissociation. Similarly, when it comes to the bases, if you look at say sodium hydroxide, when dissolved in water, it will undergo almost complete dissociation. It will give us 100% complete dissociation. Whereas if you take some other bases like NH4OH, NH4OH is called as ammonium hydroxide. NH4OH is ammonium hydroxide. Okay, so this will also undergo dissociation when dissolved in water, but this will be only partial dissociation. It will not be a complete dissociation. So bases like sodium hydroxide and potassium hydroxide, we will call them as strong bases. Sodium hydroxide, potassium hydroxide, even magnesium hydroxide, calcium hydroxide, we will call them as strong bases because they almost undergo full complete dissociation. Bases like ammonium hydroxide, we will be calling them as weak bases because they undergo partial dissociation. So the classification of a substance as a strong acid or a weak acid, strong base or weak base, is depending upon the extent of dissociation, whether it is complete dissociation or partial dissociation. Now there is one more classification that we will be often using, that is the idea of dilute versus concentrated. So what is this dilute versus concentrated? So here we are talking about dissolving the substance, whether it is an acid or a base, in water, which means the acid or base plus water is what we are going to be having in the particular solution, the aqueous solution. Now let us say for example we have a solution where there is 5% acid and the remaining 95% will be water. We have an acid which is say for example 50% acid. The remaining 50% will be water. Now when we compare these two, the amount of acid is more in the 50% solution because here it is 50% acid and other 50% is water. Here it is 5% acid and 95% is going to be water. So we will say this one where the acid is in lesser proportion, we will call it as a dilute acid, and here it will be concentrated acid. So this is a relative term. So we can only talk about, there is no absolute definition as such that okay it should be more than 70% or 80%. The idea of dilute and concentrated is a relative term. So here we can say that this is dilute and this will be concentrated. Instead, if I have say for example an acid where we have 50% acid and another side we have an acid which is say for example 95% acid, then here what we have to say is, in comparison, this is going to be called as a dilute and this will be concentrated. So the idea of dilute and concentrated is a relative term. So this is about the classification of acids and bases. So the same thing can be also used for the bases. So whenever the base amount is lesser, we will call it as a dilute solution. Whenever the base amount is more, we will call it as a concentrated solution. For the Arrhenius acids, we define something called as an basicity. Now basicity is nothing but the number of H plus ions that can be given by one acid molecule when it dissociates. So if you say, for example, the acids like HCl, HNO3, so when they dissociate, they would give only one H plus ion. One molecule is going to give us one H plus ion. So we will call them as monobasic acids. Whereas if you look at acids like H2SO4, when they dissociate, they will give us 2 H plus ions. So we will call them as dibasic acids. If you look at phosphoric acid formula is H3PO4. On dissociation, it can give us 3 H plus ion. One molecule can give us 3 H plus ion. So we will call it as tribasic. And some organic bases, they can even give us many number of H plus ions on dissociation. So we are going to be generally calling them as polybasic. So basicity is nothing but number of H plus ions that can be given by one acid molecule when it dissociates. Similarly, in the case of bases, we have acidity. So acidity of the base is nothing but the number of OH minus ions that can be given by one base molecule when it dissociates. If you take say for example the bases like sodium hydroxide or potassium hydroxide, on dissociation they will give one OH minus ion per molecule. So we will call it as monoacidic. If you look at magnesium hydroxide or calcium hydroxide, when they dissociate, one molecule is going to give us 2 OH minus ions. We will call it as diacidic. Whereas if you take say for example aluminum hydroxide AlOH thrice, it is going to give us 3 OH minus. So we will call it as triacidic. And we can even have polyacidic. So the acidity of a base is nothing but number of OH minus ions that the base can give for one molecule when it is dissociated in water. So this is the definition of the basicity of acids and acidity of the bases. Now while we talked about the Arrhenius theory of classifying substances into acids and bases, this theory has got some fundamental limitations, and that is the reason why obviously we have the other two theories. One of the first and probably more important limitation is that this theory is dependent upon dissolving the substances in water, because we do have, when we said that alkalis are water soluble bases, which means there are bases that are not water soluble. So if a substance is not water soluble, then the Arrhenius theory cannot even be applied to it. So the important limitation of the Arrhenius theory is that the Arrhenius theory is defined only for the substances which are dissolved in water. So there are bases which are not soluble in water. We don't call them as alkalis. Hence this theory is not applicable for all those type of bases. Like if you look at even ammonia, it has a basic nature. So ammonia has got basic nature. And ammonia, if you look at the formula of ammonia, it is NH3. It cannot give OH minus ions, because the definition is that the base should be able to give us OH minus ions. And even there are acids which do not give. So there are acids which do not give H plus ions. So all those type of substances, they will not be able to get categorized into acids or bases based upon the Arrhenius theory. So the first and important limitation is that this theory is related to dissolving the substance in water. Not every substance we might be able to dissolve in water, and bases like ammonia, they cannot give OH minus ions, and there are acids which will not be giving H plus ions. So all these type of acids and bases, Arrhenius theory will not be applicable for them. Now to define the definition of what is an acid and what is a base in more comprehensive manner, the Bronsted and Lowry theory has been proposed. It is a very simple theory that as per the theory, acid is any substance that can donate proton. So it is not about whether it is able to donate when dissolved in water or by itself. So acid is any substance which can donate proton. And base is a substance that will accept proton. So in that sense, we can see that the proton donors are basically the acids, and proton acceptors are the bases. So here there is no dependency on dissolving the substance in water. So this is the Bronsted and Lowry concept of acids and bases. Now as per this definition, if you look at the HCl and ammonia reaction, the HCl will be able to give H plus ion, which will be taken by ammonia. So thereby we will be able to form Cl minus ions and NH4 plus ions. So we can see that here HCl is donating a proton, thereby it is acting as an acid, and ammonia is accepting proton, thereby it is acting as a base. So the Bronsted theory is now able to explain the acidic and basic nature of substances even without dissolving in water. So as per this theory, there is no mention about hydroxyl ions. Acid is a substance which can donate proton, base is substance which can accept proton. So this theory is what we call as the Bronsted and Lowry theory. So Bronsted-Lowry theory is able to include the compounds like ammonia into the category of bases because they can accept protons. Now Bronsted and Lowry theory is also able to explain the amphoteric nature of water. So what do you mean by amphoteric nature of water is, water can react with both acids and as well as bases. So if you look at water, it can react with acids like HCl. So if you see when HCl is dissolved in water, what would happen is HCl when dissolved in water, HCl will donate proton to water, thereby we will get Cl minus and H3O plus. This ion is called as hydronium ion. H3O plus ion will be called as hydronium ion. And water can even react with bases like ammonia. In this case, water will donate a proton, so thereby we will get NH4 plus and OH minus. So what we see is that water is able to react with both acids as well as bases, and hence we will be calling water to have amphoteric nature. So the Bronsted theory is able to explain the amphoteric nature of water, whereas in one reaction we see that water is able to accept proton and act as an base. Water is itself acting as a base because here the HCl is an acid, and in this case water is donating a proton, so this is acting as an acid, whereas ammonia is acting as a base. So the Bronsted and Lowry theory explains the acidic and basic nature of water simultaneously, and hence we will be calling it as amphoteric in nature. Now the Bronsted-Lowry theory also has some limitations. If you look at there are substances which can act as an acid without involving H plus ions, without donating H plus ions. So such acids are generally electron deficit molecules. So molecules which are having electron deficit. What do you mean by electron deficit? We will be able to understand more about this in the metals and non-metals topic. So elements, they will try to form chemical compounds or chemical bond in order to reach what we call as octet structure. Octet structure is basically 8 electrons structure in the valence shell. there will be compounds which do not have this octet structure. So we'll call them as electron deficit molecules. And those electron deficit molecules like BF3, AlCl3, BCl3, all of them, they show acidic nature, and they don't show acidic nature by exchanging H plus ions. So the acidic nature of electron deficit molecules could not be explained by the Bronsted-Lowry theory, and for that there is an altogether new theory of defining substance into acids and bases, which we call as the Lewis theory, which is based on the electrons. So the Lewis theory of classifying substance into acids and bases, which is based on electrons, is able to include even these electron deficit molecules like BF3, AlCl3 and BCl3 into the acids category. So Lewis theory of acid is basically that substance which accepts pair of electrons. So that substance which can accept pair of electrons, we will call it as an Lewis acid. Base is a substance that can donate pair of electrons. So here we can see the definition is based on electrons. Substance which can accept pair of electrons will be called as an acid. Substance which can donate pair of electrons will be called as an base. In simple, we can say that acid is electron pair acceptor, base is electron pair donor. So if you look at the electrophiles means electron seeking, means they are having less electron. Like, you know, we talked about these electron deficit molecules, AlCl3, BF3, even H plus. All of them, they will be able to act as Lewis acids because they will be able to accept electron pair. Nucleophiles, the word nucleophile comes because it is a nucleus seeking. Why nucleus seeking? Generally nucleus is positive charge. So if there is an species which is having negative charge or which is having more electron density, then that particular species will be seeking the nucleus having a positive charge. So nucleophile means it is seeking nucleus, and nucleophiles are generally the molecules having electrons or the negative charge species like NH3 ammonia, H2O, and in carbon compounds we will study about these type of substances. R NH2, R means it's called as an alkyl group, and RNH2 type of substances we will call them as amines, 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 and ROH we will call them as alcohols, and F minus fluoride ion, OH minus hydroxyl ion, Br minus bromide ion, all of them they will be able to act as the Lewis bases. So in short, any substance which can accept electron pair is called as an Lewis acid. Lewis acids are generally electrophiles like electron deficit molecules or positive ions. Lewis bases can donate electron pairs. They are electron rich molecules or negative ions. So this is the definition of the acids and bases as per the Lewis theory. So these are the three prominent theories to classify the substances into acids and bases. Now as we can see, no theory can comprehensively cover all the substances into the classification. So in order to make sure that all the substances they are classified as an acid or a base because of their nature, these three theories have been proposed. So Arrhenius theory is based upon the dissolving of the substance in water, where if it is giving H plus ions means it is acid, OH minus ions means it is a base. Bronsted-Lowry theory is based upon the idea of donating proton and accepting proton. So any substance which can donate proton is an acid, which can accept proton is a base. The Lewis theory is based upon the idea of the electrons. So any substance which is able to accept electrons is called as an Lewis acid, and any substance which is able to donate electrons is called as a Lewis base. So these are the three theories of acids and bases.